Okay, so we're now going to look at the final part. And the final part is coding. Okay, I may have to disable the animation here as it may get slightly irritating after a while. So let's just do that a second before we go any further. None. So coding. Coding is something that you can do to data. And it might be a little bit hard to understand the use of this, but this is very, very useful for when we go to year 2 statistics, as it allows you to manipulate data into very useful ways. And we're going to just do this by examining what happens to perhaps the mean height of some people in a classroom. Let's say if they all stood on a chair. So before, what might be a reasonable height for a person? Let's say something like 1.8 meters. Okay, and in your classroom, you'll have a range of people at different heights. There'll normally be 1 point something meters, and I want you to think, what happens to the mean height? So what happens to the average height of people in a room if everybody stood on a chair? And let's make the chair a very, very high up chair, 1 meter. Well, if your average before was, say, let's say 1.6 meters, hopefully you're happy with the idea there that your new mean would be whatever it was before plus the 1 meter. And why is this? Well, this is because each piece of data is being uplifted, isn't it? Okay, and if you prefer, you can even sort of take some numbers. You could take a list of numbers, okay, and you could add 1 to each, and you could verify this for yourself, and you will see this result. So, is there an easy way then to recalculate the mean based on the new heights? Well, yes. If we know what the original was, we could just add 1. But what about something like the variance of the heights? So again, let's take this example here. As we can see how much they vary, it's not a massive amount, okay? Well, if everybody stood on the chairs, we would have 2.6 meters, 2.5 meters, 2.72 meters. Sure, they're all higher and the mean is higher, but how much do they sort of vary? What's the distance that each of these has from the mean height? Well, the mean has increased, but the spread is unaffected. Okay, so variance would actually be the same as before, and standard deviation then must also be the same as before. So in a nutshell for this idea, coding says when we add, subtract, multiply, and divide, and so on, how is the mean affected? And how is variance or standard deviation affected, if it is affected at all? So another example, let's pretend for our heights instead now. We're all going to become 3 times taller than we were. So if somebody was 1.5 meters from before, they would become 4.5 meters, for example. So what's going to happen to the mean? What's going to happen to the average height here? And hopefully, again, you're happy with the idea that the average height is going to go up. In fact, actually, it's going to be multiplied by 3, isn't it? The average height is going to be multiplied by 3. Well, what about the standard deviation of our heights? So let's go back to some numbers again. 1.6, 1.5, 1.72, I think they were. So if we multiplied each of these by 3, what would we have? So we would have 4.8, 4.5, and something awkward over here. So what's this? 5.16. So compare. What's happened now to how spread out the data is? Can you guess? It's become 3 times more spread out. Okay, so each difference, the magnitude of these differences, got multiplied by 3. This is the standard deviation. What's going to happen then here with the variance? Well, if standard deviation is like this and variance is like this, okay, this impact is actually going to become squared, so it's 9 times larger. Don't worry yet if it's becoming a little bit overwhelming. It's just some extra ideas to get you thinking about how spread, that means standard deviation, and variance, okay, they are affected by scaling. 3 times is a multiplication, and a multiplication or division we could call a scaling. So although they were not affected before when you were adding numbers, standard deviation and variance is affected when you multiply or when you divide. So a question may look like this. Here is some code. A code is just a rule. And we have here, how does this affect the mean? How does this affect the standard deviation? So if we have some code and we take the original and then we add 10, what happens to the mean? Well, the mean is 10 higher. So the mean will increase by 10. What happens to the standard deviation? Think about the chairs. Well, everybody is shifted upwards by 10, but the spread remains the same. So this is actually unaffected. Y equals 3x. Well, we have actually just done this one on the previous slide. This was scaling up by 3. So the mean, we saw that the mean height will definitely change. It will get bigger, as we expect, 3 times. And standard deviation will actually also get bigger, okay, by 3 times. So what's happening so far? Well, it seems as though the mean gets affected by everything. Addition, subtraction, multiplication, division. What's happening with standard deviation? Well, it seems to be only if it's in multiplication or division. Okay, and more common, you'll have 2 rules for coding. So we use BidMaths. So we multiply by 2, then we take away 5. Well, the mean is affected by everything. So the mean, okay, will be multiplied by 2 and then be reduced by 5. For standard deviation, it's only affected by the multiplication and not the minus 5. So it will be 2 times larger. And here's an example of maybe why you might do it. You could have some awkward numbers here that are unreasonably large, but you can see that they are very, very close to each other. So you may wish to code the data doing something like this. Take 1,000 off the value each time, and then divide by 10. And what would be our new values? So x is the input, the values we put in, y is the values that we get out. We would get these very neat, convenient values. And something interesting that we can do, and you must do this if the question asks you to do it this way, is we can perform some calculations on these new values. So these new values are y. And here we're being asked to find the standard deviation of y. So applying the formula, checking on your calculator and so on, you will be able to work out this answer. So the average distance from the mean for the new data is the square root of 2. But you can use this answer to find the standard deviation of the original data without redoing all the calculations. The original data was subtracted by 100 and then divided by 10. If we're looking at standard deviation, which part of this calculation affected the answer? Well, actually, it was the dividing by 10, wasn't it? And we got the square root of 2 for the standard deviation. So we can actually go backwards. If we multiply by 10, we can quickly say that the standard deviation for the original values must have been 10 root 2. So as well as going forward, we are expected to go backwards. You need to quickly check which which part of the coding is relevant for what you're talking about, and just read the questions very carefully. So some quick fire questions. This is the information before. This is the information after. And this is the code. The mean is over here. The mean is affected by everything. If you take away 20, you must take away 20 for the mean. Standard deviation is only affected by multiplication and division, none of which has taken place, so it won't change. The old mean was multiplied by 2 and became 72. If we go backwards, it will be 36. The new standard deviation is 16, and that's what happens after you multiply by 2. This does apply to standard deviation. So to go backwards, we do the inverse and divide by 2. So quickly just check by pausing the video for the last 3 that you could get the remaining values. So I'm going to assume that you have done that, and you should be able to get the values on the board. Finally, just a couple of examples for how this question may be presented. So some original price is called X. Here's the code, and we have to code the data, so we have to transform it with this. Take away 7 divided by 80. Very convenient. 807 will become 800. Divided by 80, this will become 10, won't it? Okay, over here, 960. Okay, this will become 12. So the first thing we may be asked to do is to code the data. Then we're asked to do something with the coded data. So you must use the coded data, and we can find the mean from these values. Use your answer to B. So use the mean coded, the coded mean to go backwards and find the mean of the original. And if I show you some answers here, you can see your list when it's coded. Okay, the coded mean, and then we just go backwards with the rule to find this one here. The last part is the last question is a very nice illustration. So the coded mean, so we're not getting the data, we're getting the coded mean is 18. The code used was this. What's the uncoded mean? So let's go backwards. 18 times 1,000, 18,000 plus 720. I'm doing everything because it's the mean. The mean has everything applied, and we get 18,720. And that takes you to 2F, which is the last sort of main part of content. However, there will be another video showing an alternate way of doing linear interpolation for harder questions. So just to sum up then, you should be confident finding quartiles using rules for listed data, okay, but also for grouped data. We have a grouped frequency table here with some values. The estimated mean, we will use midpoints, okay, adding the midpoints, dividing by the number of frequency. The estimated median, you will see a linear interpolation calculation, okay, and the estimate variance. So we can still do variance and standard deviation and so on with examples like this, okay? We just need to use midpoints. The midpoints factors in, okay, as you can see, when we did the estimated mean, we were getting values from this, and those values are being carried over. Usually you are given this value here. Okay, what's the standard deviation? We should be able to work out for a list of information such as this, okay, and to use codes. To use codes, the mean is 11, so the code is here. So what do? We apply everything. So we add 21 divided by 3, we should get 7. How's the variance affected? The variance was 4. The division is the only applicable part, okay, so it should be divided by 3. Just carefully checking there, it did say variance instead of standard deviation. So 3 squared is actually 9, so it's 4 nines. Something to watch out for there, variance versus standard deviation. Okay, and just another example for you on the board of coding as well.